Haloform reaction continuation part 2. In the last class we discussed haloform reactions, which compounds will undergo haloform reactions and what are the reagents that are required for haloform reactions. Three types of compounds will undergo haloform reactions. So CH3, CHOH will compounds, CH3, CHOH containing compounds will undergo haloform reaction. CH3CO acetyl group containing compounds will undergo a haloform reaction, and CX3 C double bond O containing compounds will undergo haloform reaction. And there are two reagents for haloform reaction. One is halogen in combination with sodium hydroxide, and the other reagent is sodium hypohalite. In the last class we discussed we prepared chloroform by using chlorine in combination with sodium hydroxide and sodium hypochlorite. So we prepared chloroform by using ethanol, we prepared chloroform by using acetaldehyde, we prepared chloroform by using chloral. So today we will prepare chloroform from acetone. So preparation of chloroform from acetone. Preparation of chloroform from acetone. So in the last class we prepared chloroform from ethyl alcohol and acetaldehyde and chloral. Right. So first method we will use two reagents. In the first case we will use acetone plus. Okay, so we will use this reagent. So 3 moles of chlorine plus 4 moles of sodium hydroxide. 3 moles of chlorine and 4 moles of sodium hydroxide. Why 3 moles means, so here, okay, so for 3 hydrogens, so we need to convert 3 CHCL3. To convert 3 hydrogens from 3 chlorines, so 3 chlorines are required. To abstract a proton, 3 sodium hydroxide are required. So after getting trichloroacetone, so our last mole of sodium hydroxide will attack on trichloroacetone. So okay, we will end up with the chloroform. Let's see. So here, so this one part will be converted into chloroform, another part will be converted into salt. Let's see the way of writing CHCL3. So this part is converted into chloroform and this part will be converted into salt. CH3. So for any doubt, so in the last class we spent a lot of time in the mechanism. You can practice the mechanism by seeing my last class. The side products, very important to write the side products here. So how many chlorines are there? 6 chlorines. Okay, among 6 chlorines, 3 chlorines are already utilized and the remaining chlorines are 3 sodium chloride. For 1 mole of sodium chloride, 1 mole of water will form. So remember this point. So 3H2O. Let's see, is it balanced? So 6 hydrogens plus 4 hydrogens, 10 hydrogens. Let's see how many hydrogens. 1 plus 3, 4. 4 plus 6, 10 hydrogens. Oxygens, 4 plus 1, 5 oxygens. 2 plus 3 oxygens done. 4 sodium, 1 plus 3, 4. 6 chlorines done. It's balanced. See, okay, very important. Only the important point is how to write the products. So first CH3 part is CHCL3. CH3CO part is CH3COONA. That's it. Now we will write chloroform. We will prepare chloroform from acetone by using the second reagent. There are two reagents. One is halogen in combination with sodium hydroxide. Other one is sodium hypohalite. What is the second halide? Sodium hypochlorite. NaOCl. Sodium hypochlorite. So how many moles required? 3 moles required. Why not 4? Why 4 moles not required? Okay, 3 moles is required. So why? Because why here 4 moles of sodium hydroxide? The reason is at the end sodium hydroxide is required. So whereas here So 3 is fine. Why? Because at the end, so sodium hydroxide is the side product in the reaction that will be utilized to attack on trichloroacetone. If you have any doubt, you can write the complete mechanism by taking the example of my previous mechanism. So the product obtained is, see here. So very important to write the product. So this part is a chloroform and this part is salt, CHCL3. So we will write number of examples. Okay, this part is CH3COONA, sodium acetate, CH3COONA, and then side products, 3 sodiums, 1 sodium is already utilized, 2 moles of sodium hydroxide. Let's see, check for the balancing the reaction, how many hydrogen? 6 hydrogen. So 3, 4, 4 plus 2, 6. 3 sodium, 2 sodium, 1 sodium, done. Oxygens, 4 oxygen, 3 plus 1, 4, 2 plus 2, so it's balanced. So last example, trichloroacetone. So this trichloroacetone is supposed to get from the either here or here. If you write the mechanism, you will clearly understand. This is trichloroacetone. When trichloroacetone reacts with 1 mole of sodium hydroxide, actually this is a part from this reaction. So this step is the final step in both these. If you write the mechanism, you will see this step at the end of the mechanism, right? So here finally we will get trichloroacetone, here also finally we will get trichloroacetone, right? So here only 1 mole is required. This part is chloroform part, this is sodium salt. So CHCL3 and then sodium acetate. So CH3COONA, hydrogen here, sodium ONA part here. Any doubt, you can write the complete mechanism. Sodium acetate. Clear? Right. So this is the way to prepare chloroform from acetone. So now we will prepare bromoform and idoform by using 2 reagents. So halogen in combination with sodium hydroxide and sodium hypohalite. Clear? So far we prepared chloroform from ethyl alcohol, chloroform from acetaldehyde, chloroform from acetone, and chloroform from trichloroacetone, chloral, and chloroform from trichloroacetone. Now we will prepare bromoform. So we will prepare bromoform from ethyl alcohol, acetaldehyde, and acetone. Right. So what is bromoform? CHBr3, trihalogen derivative, it's a bromoform. There are 2 reagents for the preparation of chloroform or haloform or bromoform, idoform. What are the 2 reagents? Bromine in combination with sodium hydroxide, and other reagent is sodium hypobromite, NaOBr. Okay. So for any doubt in the mechanism, you can check my previous video for complete mechanism. It is very important, especially, okay, so why? Because this type of reactions will come again and again in 3 different chapters: alcohol chapter, aldehydes and ketones, and carboxylic acid. That's why it is important to practice the mechanism thoroughly. Now first we will prepare bromoform from ethyl alcohol. So I am writing directly the product. Why? Because so regarding the mechanism we spent a lot of time in the previous class. Regarding from ethyl alcohol to bromoform, it requires 4 moles of bromine and 6 moles of sodium hydroxide. Right. So why 4 moles of bromine means 3 moles of bromine is to convert 3 hydrogens to 3 bromines. Another mole of bromine is to convert alcohol to aldehyde. Okay, regarding 6 sodium hydroxide, 3 sodium hydroxides to abstract a proton here. 1 sodium hydroxide is at the final step to attack at chloral. 2 sodium hydroxides to convert alcohol to aldehyde. For any doubt, you can check my previous video for complete mechanism. So this part is bromoform and this part is sodium salt, CHBr3. then HCOONA, and then okay, so 5 moles of sodium chloride, sodium bromide, not chloride. Why? Because we have used bromine. And then for 1 mole of salt, 1 mole of water will be obtained. Let's see the balance. Let's see the balancing. How many hydrogens are there? 6 hydrogens and 6 plus, okay, 6 plus 6, 12 hydrogens are there. 1, 2, 2 plus 10. Okay, 12 hydrogens. How many oxygen? 7 oxygen. 2 plus 5, 7. How many sodium? 6. 6, 1. Right, clear. It's balanced. 8 bromines. 5 plus 3, 8 bromines. Now, similarly, so we can prepare bromoform by using 2 reagents. From one starting material, 2 reagents. What are the another reagent? Sodium hypobromide. How many moles of sodium hypobromide? 4 moles of sodium hypobromide. So why 4 moles? Why not 3 moles? So 3 moles is used to convert 3 hydrogens to 3 bromine. 1 mole of sodium hypobromide is used to convert alcohol to aldehyde. So this part is CHBr3, and then sodium formate HCOONA, and then so okay, so here one molecule of sodium bromide, 1 molecule of water, and 2 molecules of sodium hydroxide. So always practice several times, then only you can easily write the complete side product. Let's see the balancing the reaction. So how many moles of oxygens? 5 moles of oxygens. So 5 moles came here. So 2 plus 2, 4 plus 1, 5. How many hydrogens? 6. 1, 3. 3 plus 2, 5. 5 plus 1, 6. 4 bromines. 3 plus 1, 4. 4 sodium. 1, 2 plus 2, 4. It's balanced. Now see. So this is the way of preparation of bromoform from ethyl alcohol. Now we will prepare bromoform from acetone. CH3, C double bond O, CH3. So this is acetone. So we can prepare bromoform by using 2 reagents. One is bromine in sodium hydroxide, the other is sodium hypobromide. So first bromine in sodium hydroxide. Here 3 moles of bromine is required and 4 moles of sodium hydroxide. Why only 3 moles means? So already we have CH3 here, right? So it's a keto compound. So 3 bromines is used to convert 3 hydrogens to 3 bromo. So 4 moles of sodium hydroxide means 3 moles are utilized for the conversion, for the abstraction of 3 hydrogens. And the last mole is used to attack at trichloroacetone. The products obtained here, always this part is chloroform part and this part is salt form. Okay, let's see the way of writing. CHBr3, and then so this is the salt form, CH3COONA, CH3 sodium acetate, and then okay, 1 mole of sodium bromide. Okay, let's see 1 mole. Okay, so okay, let's see sodium bromide. Okay, how many moles of bromine? Right, 3 moles of sodium bromide and 3 moles of water. Let's see balanced or not. Oh, how many hydrogens? 6 plus 4, 10 hydrogens. 1, 4, 4 plus 6, 10 hydrogens. Sodium, 4 sodium, 1 plus 3, 4, balance, 6 bromines. Okay, 3 plus 3 into 2, 6 bromines, 3 plus 3 bromines. Oxygens, 5 oxygens, 2 plus 3, it's balanced. So similarly, so bromoform can be prepared from acetone by using sodium hypobromide, NaOBr. How many moles? 3 moles is fine. Okay, 3 moles is fine. Why only 3 moles means? To convert 3 hydrogens, 3 moles is fine. So at the end we will get a trichloroacetone. So the side product is sodium hydroxide that will attack in situ. That's why sodium hydroxide is not separately required here. The product formed is CHBr3. So practice this reaction several times. This part is from the bromoform and this part is for the salt form CH3. See the way of writing sodium acetate. This part is for the chloroform and this part is for the salt form, and the side products are, so 1 molecule of sodium bromide and 1 molecule of water and 2 molecules of sodium hydroxide. Let's see whether the reaction is balanced or not. Okay, how many hydrogen? 3 plus 3. Okay, 6 hydrogens are there. This reaction 1, 4 plus 2, 6 hydrogens. How many oxygens? 3 plus 1, 4 oxygens. 2 plus 3, okay, 5. Okay, so how many oxygens? 3 plus 1, 4. Okay, 4. 3 oxygens are there. CH3, CO, ONA, H2O. Okay, how many sodium hypobromide? 3 sodium. 1 plus 2. Okay, see somewhere. Okay, only 1 molecule of sodium hydroxide. Why? Because, okay, right, 1 molecule of sodium hydroxide only. Let's see, is it balanced? Okay, so sorry, sodium bromide will not be obtained here and water will not be obtained. Let's see, 2 molecules of sodium hydroxide will be obtained here. Okay, so always we need to practice several times, so then only we can able to write. Okay, after practicing also, so we got some mistake here. Let's see how many hydrogens are there. 6 hydrogens. 1 plus 3, 4 plus 2, 6 hydrogens. So for any doubt you can write the complete mechanism, so then only it will come very perfect way. So 3 bromines, okay, that's all. 3 sodium, 2 plus 1, 3 sodium. 3 oxygen, 3 plus 1, 4 oxygen, 2 plus 2, okay, clear, okay. Sodium bromide will not be obtained here, only sodium hydroxide will be obtained, okay. So another way is, last way is tribromo acetone. So this tribromo acetone will be obtained here. So this reaction with this reaction finally will end up with the tribromo acetone. So when ethanol reacts with the sodium hypobromide, we will end up with the tribromo acetone. Ethanol reacts with 4 moles of bromine, we will end up with the tribromo acetone. When acetone reacts with bromine and NaOH, we will end up with the tribromo acetone at the final step. When acetone reacts with 3 moles of sodium hypobromide, we will end up with the tribromo acetone. In the final step, it will react with sodium hydroxide. This bond will be broken. CHCbr3H, CHBr3, CH3COONA. Simple reaction. CHBr3 and CH3COONA. See, so always we need to practice this reaction several times, then only we can write the side product. So no one will ask you side products. Only the thing is we have to mainly focus at bromoform and salt form. So in case of 2 carbons, there is no problem, sodium formate will be obtained. In case of 3 carbons, sodium acetate. Suppose if the length increases here, so we need to be very careful which compound will give CHBr3, which will give sodium formate. Always CH3 group will give chloroform, the other length carbon will give you salt form. Now similarly, if you take bromoform, so preparation, so chloroform is over, so we covered all the examples. Bromoform is over. Let's see idoform. So clear? Okay, now idoform. So no need to write separately. So I will include idoform in the same reaction. So what is idoform? Idoform, CHI3. CHI3. For idoform, we need iodine in presence of sodium hydroxide and sodium hypoiodide. Okay, chlorine sodium hydroxide chloroform, sodium hypochlorite chloroform, bromine sodium hydroxide bromoform, sodium hypobromate bromoform, iodine sodium hydroxide idoform, sodium hypoiodide idoform. Okay, 2 reagents for idoform, haloform reactions. One is halogen in combination with sodium hydroxide, other is sodium hypohalide. So we will prepare idoform by using ethanol, acetone and triiodoacetone. We will change at the end. So when ethanol reacts with 4 moles of iodine, 6 moles of sodium hydroxide, we will get idoform, CHI3. Okay, you can write separately. So any doubt you can write complete mechanism. The remaining part is same. So the side products are 5 moles of sodium iodide. Okay, let's see. 4 moles of iodine and 6 moles of sodium hydroxide. 6, okay, done. So 8 iodines, 5 plus 3, 8. 6 sodium is down, it's balanced. Similarly, when ethanol reacts with 4 moles of sodium hypoiodide, NaOI, it gives 1 mole of idoform, CHI3, and then sodium formate 1 mole, and no sodium bromide, sodium iodide will be obtained here. And then for 1 mole of salt, 1 mole of water, and 2 moles of sodium hydroxide. Balanced 3 iodines. Okay, 4 iodines, 3 plus 1, 4. Done. So similarly, preparation of idoform from acetone. When acetone reacts with 3 moles of iodine and 4 moles of sodium hydroxide, we will get 1 mole of idoform and 1 mole of sodium acetate. This part is idoform, this part is salt form, and sodium iodide, 3 moles of sodium iodide and 3 moles of the water. Similarly, acetone reacts with 3 moles of sodium hypoiodide to give 1 mole of idoform. Okay, acetone, done, that's it. Similarly, triiodoacetone reacts with sodium hydroxide. We will get 1 mole of idoform and then 1 mole of sodium acetate. So no need to confuse. Let's see overall reaction. The formation of haloform. For a haloform, which compounds will undergo haloform reaction? CH3CO, CH3CO, CH3CHOH compounds will undergo haloform reactions. What are the reagents? 2 types of the reagents: halogen in sodium hydroxide and sodium hypohalide. Either chlorine sodium hydroxide, bromine sodium hydroxide, iodine sodium hydroxide, or sodium hypochlorite, sodium hypobromate, or sodium hypoiodide. For idoform, from ethyl alcohol, 4 moles of iodine and 6 moles of sodium hydroxide. In case of sodium hypoiodide, 4 moles of sodium hypoiodide. Why so 4 moles of sodium hypoiodide? Means 1 mole is used to convert alcohol to iodide, alcohol to aldehyde, and then remaining 3 moles will be used to convert 3 hydrogens to 3 iodines. So similarly, acetone, 3 moles of iodine, 4 moles of sodium hydroxide, 3 moles of sodium hypoiodide, right? So finally, triiodoacetone requires only 1 mole of sodium hydroxide. Let's see one more important point. If you react ethanol with here, finally we will end up with triiodoacetone. Ethanol with sodium hypoiodide, finally we will end up with triiodoacetone. Acetone with iodine sodium hydroxide, the final step is triiodoacetone. Acetone with sodium hypoiodide, the final step is triiodoacetone, when that reacts with sodium hydroxide to give idoform and sodium acetate. Clear? So practice several times, then only it is easy to write the side products as well as the product. Now we will solve some more examples. Preparation of bromoform from acetaldehyde. So earlier we covered bromoform from and idoform from ethyl alcohol and acetone and trichloroacetone we covered. Now bromoform and idoform from acetaldehyde. When acetaldehyde reacts with 3 moles of bromine, since bromine we are using 3 moles of bromine and 4 moles of sodium hydroxide to give, this part is bromoform and this part is salt form, to give 1 mole of CHBr. See the way of writing, very important. 1 mole of sodium formate, CH3COONA. For any doubt, you can check the previous video for complete mechanism. And 3 moles of sodium bromide and 3 moles of water. Let's see the balancing the reaction. How many hydrogens? 4 plus 4, 8 hydrogens. 1, 2, 2 plus 6, 8. How many oxygens? 4 oxygens. 2 plus 3. Okay. So how many oxygens? 4 plus 1, 5 oxygens. 3 plus 2, 5. Right. Okay. 4 sodiums, 4 sodiums. Done. So similarly, when acetaldehyde reacts with 3 moles of sodium hypobromide, so we will get bromoform. So this part is chloroform and this part is salt. bromoform and 1 mole of sodium formate. That depends on the chain sodium formate, and so 3 bromines is over and 2 moles of sodium hydroxide. Let's see, balancing the reaction, 4 hydrogens. So this reacts 1, 2 plus 2, 4 hydrogens, 3 plus 1, 4 oxygens, 2 plus 2, 4 oxygen, 3 sodium, 2 plus 1, it's balanced. So this is the way of preparing bromoform. So similarly, tribromo acetaldehyde. This tribromo acetaldehyde will be getting when acetaldehyde reacts with bromine in NaOH as well as sodium hypobromide. This is formed at the final step. When tribromo acetaldehyde reacts with 1 mole of sodium hydroxide, so this part is chloroform and this part is for the salt form, we will get to bromoform plus sodium formate will be obtained. So this is the way for the preparation of bromoform from acetaldehyde. So similarly, we will prepare idoform. So no need to write separately. For idoform, we just change the reagent. Idoform, preparation of idoform from acetaldehyde. Okay. So take here iodine, 3 moles of iodine. Okay, we will get 3 moles of 1 mole of idoform CHCL3 SO. So here we will get 3 moles of sodium iodide. Right. Similarly here 3 moles of sodium hypoiodide, we will get 1 mole of idoform, and that's it. Okay, 1 mole of idoform, sodium form, now it's balanced. Similarly, so here, so reaction of acetaldehyde with, reaction of acetaldehyde with iodine, sodium hydroxide, or acetaldehyde with sodium hypoiodide, we will end up with 1 mole of triiodoacetaldehyde, which on reacts with sodium hydroxide, we will get idoform. Okay, so this is the way of preparation of chloroform, bromoform, idoform from ethyl alcohol, acetaldehyde, acetone, trichloroacetaldehyde or trihaloacetaldehyde or trihaloacetone. Clear? Next we will discuss some important notes and physical properties. Clear? Haloform reaction, we will write one important note. Haloform reaction is used to prepare either chloroform, bromoform or idoform. Compounds which contains CH3CHOH group, CH3CO group or CH3CO groups will undergo haloform reactions. 2 types of reagents, halogen combination with sodium hydroxide or sodium hypohalide are used to prepare haloform, chloroform, bromoform or idoform. So one important, I am just writing a conclusion for the moles. If it is alcohol, we need 4 moles of X2 and 6 moles of sodium hydroxide, or 4 moles of sodium hypohalite. Clear? If it is keto compound, okay, or aldehyde or keto, okay, either aldehyde or keto, it needs 3 moles of X2 plus 4 moles of sodium hydroxide or 3 moles of sodium hypohalite. If it is trihaloaldehyde or ketone, it requires only 1 mole of sodium hydroxide. Very important point. Okay, so if you remember this particular point, we can apply this point to any examples. So regarding the side product, this part is chloroform. This part is chloroform, and whatever the rest part is salt form. Sodium formate, sodium acetate, sodium propionate, sodium butanate, like that. Okay, that depends on the length of this chain. So this is about haloform reactions. Okay, we covered all examples and all equivalents. Now coming back to chloroform, physical properties of chloroform. Physical properties of chloroform. So we have only chloroform in our syllabus. Regarding the synthesis, since we are discussing haloform, we covered bromoform and idoform. Okay, right. So regarding the physical properties, it's a colorless liquid. It's a colorless liquid, sweet smelling liquid. It's sweet smelling. Smell is sweet smell. Heavy liquid. Heavy liquid means the density is more. The density of chloroform is equal to 1.45. Heavy liquid. Boiling point 334 Kelvin. Boiling point 334 Kelvin or 61 degrees centigrade. Solubility. Soluble in organic solvents. Soluble in organic solvents like ether, alcohol. Insoluble in water. Why? Because organic solvent. Insoluble in water. Last important point, if you inhale chloroform, it brings unconsciousness. If you inhale chloroform for a longer time, it brings unconsciousness. That's why it is used as an anti-anesthetic drug in the olden days. Okay. So this is about today's class. In the today's class, we covered haloform reactions. So preparation of chloroform from acetone, preparation of bromoform from alcohol, aldehyde and trihalogen compounds, preparation of idoform from alcohols, aldehydes and ketones from and trihalo compounds we covered. And also physical properties we covered, and we made one important note regarding the equivalence of the halogen in combination with sodium hydroxide and sodium hypohalate. In the next class, we will discuss chemical properties of the chloroform. So follow the class, read well, all the very best. Thank you.